Create a table of values for the following equations. Then determine the rate of change for each equation. Finally, graph the equation on the Cartesian coordinate system. So this equation y equals 3x minus 7 has two variables, x and y, and we can think of x as the input and y as the output, which means if we choose a value of x, we can find out what value of y we get when we plug that value in for x. So for instance, we could choose 0 as an input. If we choose 0 as x, then 3 times 0 is 0, and 0 minus 7 is negative 7. So when x equals 0, y equals negative 7. And we can choose any inputs that we want, but I'm going to choose a few positive x's, and I'll even choose a few negative x's. The reason I want to do this is so that when I graph this equation, I get an idea of what the whole graph looks like. If I were to only choose positive x's, I might not really see the entire shape of the graph. So as we plug these values in, I'm going to go ahead and plot them on our grid. So 0, negative 7 would be this point here on the y-axis. Now, let's plug 1 in for x. 3 times 1 is 3, and 3 minus 7 is negative 4. 1, negative 4 is here. If we plug in 2 for x, 3 times 2 is 6. 6 minus 7 is negative 1. 2, negative 1 is here. If we plug in 3 for x, 3 times 3 is 9. 9 minus 7 is 2. 3 comma 2 is here. If we plug in 4 for x, 3 times 4 is 12. 12 minus 7 is 5. 4 comma 5 is here. Now we can see that all of the points that we've plotted so far appear to lie on a line. Let's see if this continues to be true when we put in negative x's. When x is negative 1, 3 times negative 1 is negative 3. Negative 3 minus 7 is negative 10. Negative 1 comma negative 10 is here, right at the edge of our grid. And if we plug in negative 2, 3 times negative 2 is negative 6. Negative 6 minus 7 is negative 13, which won't fit on our grid, but we could imagine negative 2, negative 13 would be right about here or so. So it appears that whether or not we put in positive values of x or negative values of x, all of these points lie perfectly on a straight line. Now, we're asked about this rate of change for this equation. Now, the rate of change would be the change in y, or how much the y's change per x. So, for instance, you'll notice if we look at this table a pattern. We see that the y's are going up by 3. And the y's are going up by 3 as the x's go up by 1. So the rate of change would be 3 y's per 1x, or 3 divided by 1 y's per x. And 3 divided by 1 is simply 3. So a rate of change is 3.